Hello and welcome back to my YouTube channel. In this video, I'll be going through bit manipulation in C and Arduino programming. Now, before we can actually get started with the programming, there is a bit of preliminary knowledge that we need to cover surrounding digital logic. Now, in digital logic, there are many digital operators. However, we'll only be looking at four main ones. They are the OR operator, the AND operator, the exclusive OR operator, and the NOT operator. Now, what the OR operator does is it takes in two binary inputs, a low or a high value, or if it's easier, a 0 or a 1. And what it says is the value of ORing two values is high if either of them are high, or if either of them are 1, then the value is 1. So let's fill out a truth table for the OR operator. Suppose we have two values x and y, and we wish to OR them. Then x and y can have numerous permutations. We can have either x and y as 0, in which case ORing them will obviously give out 0, since neither of them are high or 1. Another case we can have is if x is 0 and y is 1. Well, since one of the values is 1, namely y, ORing them will give out 1. Likewise, if we have x as 1 and y as 0, then x or y will give out 1. And if x is 1 and y is 1, well, OR includes AND, since, x and y are 1, well, obviously one of them is 1, so x or y will give out 1. Now let's move on to the AND logic operator. What the AND logic operator says is the value will only be true or high or 1 if both inputs were true or high or 1. So we can have x as 0 and y as 0, in which case they are both not 1, so the value cannot be 1 and must be 0. If we have x as 0 and y as 1, then they are both not high, so we can't get a high output. If x is 1 and y is 0, then once again they are both not high or they are both not 1, so we can't get a 1. However, if x is 1 and y is 1, that is, they are both high, they are both 1, then our value will come out to be as 1. Now we move on to the exclusive OR operator. This operator is very similar to the OR operator, except that it does not include the case where they are both high or both 1. That is, it is exclusively ORed. It needs exclusively one or the other to be high. It cannot have both. So we start again. What if we have x as 0 and y as 0? Well, neither of them are 1, so we can't have a 1. It must be 0. What if x is 0 and y is 1? Then we have one of them as high. That is, we can say x or y has one of the values as high, so we have a 1. Likewise, if we have x as 1 and y as 0, then one of the values is a 1, and so we get out a 1. However, what if we have x as y and y as 1? Since this is an exclusive OR, we need it to be exclusively one or the other has to be high, cannot be both. We also get a 0. Now let's move on to the final one. That is the NOT operator. The NOT operator is a unary operator. That is, it only takes in one value. So x can be either 0 or 1. And what notting it does is essentially inverts it or flips it. So 0 will become a 1 and a 1 will become a 0. Let's now look at some of the subtleties of these operators and see if we can notice any nice patterns. What we should notice about the OR operator is when we OR a 1 with anything, we always get a 1. So notice, when x is 0 but y is 1, we get a 1. Also, when x is 1 and y is 1, we get a 1. So in any case, whenever ORing a 1 with any other value, we always get a 1. Conversely, with the AND operator, whenever ANDing with a 0, we always get a 0. If we have x as 0, then no matter what we AND it with, we will always get a 0. Likewise, even if x is 1, if we AND it with a 0, we will get a 0. Now the exclusive OR operator has something really nice that we should notice. If we have a value of 1 in the exclusive OR, as in this case, then if we OR a 1 with this 0, we get a 1. And if we exclusively OR a 1 with a 1, we get a 0. What seems to be happening is when we OR a value with a 1, it will flip that value. It will toggle it, so to speak. So here we have a 1. I want to exclusively OR a 0 with it, then the 0 will be toggled to a 1. Likewise, a 1 will be toggled to a 0. Now let's talk about bit shifting. We know in binary that the value for 1 is zeros everywhere except for the last digit being a 1. So a 1 in binary would look something like this if we were to use only 8 bits. Now let us let this value equal x. Now in C, if we write the following line, it will shift the value. So if we type in C x, then 2 of these, and then say 5, it will shift the value 5 spaces. But what does that mean? Well, it takes every digit and moves it down 5 spaces. Since we have zeros all here, then shifting a 0 to another 0 doesn't change anything. But let's look at the 1. We can shift the 1 5 places. So 1, 2, 3, 4, 5. And so the result of bit shifting this will be a 1 written in this place. But the question is, what happens to the original 0 that, to the original 1 that we had? What happens to this value after we shift it? Well, it just turns to a 0. And so the value of shifting x by 5 places is the following. Now once again, let's try and notice some subtleties about this. If we number the binary bits starting at index 0, we'll notice something very nice. So this will be the 0th bit, this will be the 1st, the 2nd, the 3rd, the 4th, 5th, 6th, and 7th. And likewise here we will have the same. Now we shifted x by 5 places. And notice, after shifting x by 5 places, the 5th index now has a value of 1 added. This will be very important and very useful when we now program. So I'm going to open up the previous Blink program we did in the last video, and now I'm going to use bit shifting. So previously we had to set the 5th bit in this register to be an output. But what I can instead do now is define a constant called LED pin, and it's going to be 5. And here, instead of doing this, because I now know that ORing a 1 with anything will turn that bit to a 1, I can say this. I want DDRB to be whatever DDRB currently is, ORed with a 1 in the 5th bit place. So a 1 shifted to 5 bits to the left. However, I don't even need to do this anymore because I have a constant called LED pin. Now what this does is it sets the 5th bit to a 1, and then ORing it with the current value of DDRB will set that bit to a 1, because ORing anything with a 1 will be a 1. Now I can tidy this up a little more. In C, we can use the assignment operator and just type this. And what this does is it takes the old value of DDRB, ORs it with this, and then that new value will be what DDRB is. Likewise, I can do something similar with port B. I can say port B should equal whatever port B currently was or currently is with a 1 in the place of the 5th bit or my LED pin. However, once again, I can clean this up and I can just say this using the assignment operator. And I'm going to do the same here. However, now I want to turn off that bit. Now let us recall from digital logic that ANDing anything with a 0 will turn that bit to a 0. So port B equals port B ANDed with 0B 00. That's what we currently had, but now I want that bit now to be 0 and so on. But typing this isn't nice. So what I want is just to figure out a way to turn off this bit here. How can I do that? Well, if I have the value 0000000001, that is the value 1 in binary, and I shift it to the left by 5 places, we already saw that what will happen is we will get this bit to be a 1 and this is now a 0. What if we then do a not operator? That is, flip it. How do we do not? We use this tilde operator or tilde key. And what this does now is it flips all the other bits. And so we get 1 1 0 1 1 1 1. And I think there should be one more one. Yes. And what's nice about this is 1 ANDed with anything will be whatever that thing originally was. So say we have a 0. 0 ANDed with 1 is 0. We originally had 0. Now we can do this quite nicely by saying this. Port B should be 1 LED pin shifted. So now the 5th bit is 1, but I don't want the 5th bit to be 1. I want the 5th bit to be 0. So I should not it. How do I not it? I just use this tilde key. And once again, I can simplify all this and I can say port B should be ANDed with whatever port B is, but I should have 1 LED pin and I cannot forget to not it. Okay, let's save this. Let me compile it. It works okay. And let me now upload it to the board. And we can see it blinks just fine. Now let's see if we can clean up this code even more. What I'm now going to do is use the exclusive OR not to turn on and off the LED, but rather to toggle it on and off. Now, we did previously see that doing an exclusive OR with a 1 with any other value, so pick a value, if you do an exclusive OR with a 1 with that value, then you end up toggling that value. What value do we want to toggle? The value in the LED pin. So, I'm going to say port B should equal whatever port B is, and then I want to toggle that value. I want to toggle the value in port B. So I should write a 1 to the value I want to toggle. I want to toggle the LED bit. I write a 1 and I can do this. And this here is the exclusive OR operator. And then I can do my delay. And I'm going to delay for 1 second. Okay. Now I can clean this up even more, once again, using the assignment operator. I want this operator, And I'm going to say that. Okay, let me save it. Compiles just fine. And let me upload it to the board. And we can see it toggles. Now, just to make sure this is actually working, let me try and make this delay a little shorter. And let me upload it to the board. And we can see that the LED is now flashing much faster. Now, that will be all for this video. Thank you all for watching, and I'll see you all in the next one. Bye-bye.